You with me? You can just FOIL all that out and combine them if you want, but you guys are watching me, so. That has to be 6, that has to be -3, and that has to be 1. Why? Because I got a parabola on this side, and I have a parabola on this side, and this equal sign says they're the same parabola. You can't have two parabolas that have different coefficients. 3x squared minus 2 equals 4x squared minus 2. That can't be, there may be some values of x for which it's true, but it can't be the same parabola. So, combining, mixing and matching here, a plus 4b has to be 6, b plus 4c has to be -3, and a plus c has to be 1. I'll start it, but I won't finish it. I need to eliminate one of the variables here. So if I multiplied this one by say -4 and added to this one, it would get rid of some of it. So like using the bottom two, b plus 4c is -3. Multiplying this one by -4, -4a minus 4c equals -4. Now adding those, I get b minus 4a equals -7. You see what I'm doing? I've now got two equations in just a's and b's. So then I can combine those two. A plus 4b is 6. -4a plus b equals -7. Multiply this one by -4, by +4 and add, and I get 4a minus 4a, that's nothing. 16b plus b is 17b. Multiply this one, 24. What's 24 minus 7? 17. Oh, b is 1. Now I plug b equals 1 back into here, I get c. I plug c back in here, I get a. I'm done. But the process there has to be, I've got to combine two of these. Since this one has a's and c's, this one has b's and c's, this one has a's and b's, somehow I've got to start eliminating to get somewhere. And so I combined these last two to get equations in only a's and b's. Okay? Anything else on the test, or are we good?
On number 6, I didn't know what I was doing.
Pardon?
On number 6,
Right?
I had no idea what I was doing.
What was it?
Number x equals 1 over square root of x. For x is greater than 0.
Say it again?
It's a sketch a graph one.
Oh. Right, sketch graph and compute the improper integral from what? 0 to 1 or 1 to infinity? What was
1 to 0.
0 to 1. So, well, a graph is just this. Put a million in. 1 over the square root of a million is a tiny number. Put a tiny number. 1 over the square root of a tiny number is a huge number. I'll put 1 point on it. 1 1. Done. Integral 1 over square root of x from 0 to 1 meant I need to look at the limit as t goes to 0 from the right of the integral from t to 1 of, and I'll rewrite it as x to the -1/2 so I can integrate it. Now I'll integrate it. X to the +1/2 times 2, because 2 times that is 1, x to the -1/2, from t to 1, limit as t goes to 0 from the right, limit as t goes to 0 from the right of 2 times the square root of 1 minus 2 times the square root of t. As t goes to 0, that goes to 0. That doesn't go anywhere, so it's 2. So this region is unbounded, but it has area of 2. Which I still think is pretty cool that you can have an unbounded region. The region can be unbounded, but the area can be finite. All right. Good on the test. Any questions there? We good? All right. Okay, Scorpio, you had a problem you were struggling with that you'd ask to see again?
It was sine n pi over 3.
Right. So the question was monotonic. So if we just start listing out terms, then we get sine of pi over 3, sine of 2 pi over 3, sine of 3 pi over 3, sine of 4 pi over 3, sine of 5 pi over 3, dot, dot, dot. Now if we look at sine, there's 2 pi, there's pi. So here's pi over 3, here's 2 pi over 3, here's 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. So if we look at the values for this, and we can plug them into our calculator, but we can also just see what's going on. So just looking at the graph there, I mean, I can compute these. Sine of pi over 3, look at the unit circle, pi over 3 is right there. That's root 3 over 2. So I know for a fact this height here, or this here height, is root 3 over 2, and this depth is negative root 3 over 2. So if I write them out, I've got root 3 over 2, root 3 over 2, 0, negative root 3 over 2, negative root 3 over 2, 0. So if I think of those as A1, A2, A3, A4, A5, A6. You with me on what I've done so far, Scorpio? I got them all listed out there? A1, 2, 3, 4, 5, 6. What are they? They're sine pi over 3. That's root 3 over 2. Sine 2 pi over 3 is the same height. Root 3 over 2. Sine 3 pi over 3 is down to 0. Sine 4 pi over 3 goes negative. Negative root 3 over 2. Now, looking at the picture, are these dots always increasing? No. Are they always decreasing? No. Are they non-increasing? Remember, non-increasing means you can be the same for a while, but you can never go up, right? Non-increasing means you never, a sub n plus 1 is never bigger than a sub n. It never takes a step upwards. So you can go stair-stepping down, but you can never go up.
Can you just plug that in the calculator?
Yeah, you can. And the numbers you're going to get is that's about 0.86. That's about 0.86. That's still 0. That's negative 0.86. That's negative 0.86. 0.
I think I just plugged it in wrong.
Okay. But you see now, it looks like to here it's non-increasing, right? From here to here to here it's non-increasing. Goes straight across and then down. Even to here it's still non-increasing, still non-increasing. But now it quits being non-increasing right here because it starts turning back up. So what do I have to write on a test though if I say prove this is monotonic or state why it's not. What do I have to say? It's not non-increasing because what? Let's see. Yeah, now I gotta think. Non-increasing means the n plus 1 is greater than or equal to the nth, right? It's going down. So what makes it non-increasing? I mean, not non-increasing?
So we have to use the definition to explain why?
You got to know the definition, because otherwise you won't know what to write down.
I was going to put it's non-increasing because it never...
Because what?
Going down. It never went up.
It never went up is a valid answer, but it does go up some. Well, is a valid statement, but it's not true. It does go up from here to here, doesn't it? So you can't say it never goes up, because it does go up. It goes up again here. Right? It goes up from here to here to here. So there are places where it's increasing, right? Non-increasing means a sub n plus 1 always must be greater than or equal to the last one. So here it's non-increasing to here, but here it decreases. I wrote that wrong, didn't I? I'm looking at it, losing my mind. What is non-increasing?
It goes down.
Not always going down or horizontal. So if I want to show it's not non-increasing, what do I have to show? Show for some n what? At some point it steps up. Not always, just at some point. So this sequence is non-increasing because which one goes up? 1, 2, 3, 4, 5, and 6. A sub 5 is less than a sub 6.
So it is non-increasing?
No, this one's not non-increasing. Non-increasing means the nth plus first one always has to be less than or equal to. Non-increasing goes with decreasing, right? Decreasing, a sub n plus 1 less than a sub n. Non-increasing, a sub n plus 1 less than or equal to a sub n. Increasing, a sub n plus 1 greater than a sub n. Non-decreasing, a sub n plus 1 greater than or equal to a sub n. I know, the language is baffling. It's all the double negatives that make it hard. It's not non-increasing. Means this is not true. If it's not always true that a sub n plus 1 is less than or equal to a sub n, then what does that mean? There must be some n such that a sub n plus 1 is bigger than that. That's why I went ahead and... It's not non-increasing because there is some n for which this is not true. So I need to show for some n that this is true. So I need to show this is all you have to write. That's what I'm pointing out. This is how I figured out what I needed to write. Okay. Other questions? Anything? Mm-hmm.
The lowest upper bound is always the number approaching to the right. Basically, what?
No. But that's sometimes correct. So let me give you an example. You said the lower bound is always the number it approaches from the left, right?
Right.
From the
Why
right.
are you going to the right?
Yeah, from the right. Okay. So let me give let's do an example. let's look at this one and let's talk about what we're supposed to be able to prove, and let's talk about the language too, because I want to get you kick-started into the conversion part, and so let me just go ahead and do that today. So here's a sequence. Let's write out some terms, and let's look at it on a number line. What's the first term? 2 minus 1 is 1. What's the next term? 2 minus a half is 1 1/2. The next term, 2 minus a third is 1 2/3. 2 minus a fourth, 1 3/4. Right? So now first to answer your question, Dominique, what's the lower bound for this?
1 was what?
1, right? Is it heading towards that? No. But what you said, if I flipped it around, right, if it was decreasing from above, and it were heading towards a number, not negative infinity, then that would be the lower bound. Which is why I said what you said is sometimes true. Right? But in this case, it's certainly not true. So let's do our intuition. What's the greatest lower bound for this one? 1. What's the least upper bound for this one? 2. What does this converge to? 2. Is it monotonic? Yeah, why? Because it's increasing. Okay, so we all understand it. Let me say, does it converge or diverge? It's convergent, right? Because we decided it converged to 2. So let's be careful with that language. Let me say it at least one time precisely. If it doesn't converge, we say it diverges. So diverges is just the opposite of convergence. If I say it's convergent, what does that mean? There's some number to which it converges. Okay? So diverges equals does not converge to any number. Convergent equals there is some number to which it converges. Now, let's prove everything there is to prove. Let's put a number line up here first and write a bunch of them. A1, A2, A3, A4, A5, A99, right? 1, 1 1/2, 1 2/3, 1 3/4, 1 4/5. Right? We're good on the picture. Any questions on the intuition on any of this? Is this the only lower bound? No. What's another lower bound? 0. What's another lower bound? Yeah. There's how many lower bounds are there? Infinitely many. Why do I call this the greatest lower bound?
Is it n equals 1?
Well, I call it the greatest lower bound because no other lower bound is greater than it. You pick any number greater, it's not a lower bound, is it? Because one of the numbers is less than it. Of all the lower bounds, it is the largest. Of all the upper bounds, this one is the least.
Does that have any correlation to the n equals 1 up there in the problem?
Nope.
The greatest lower bound
No,
of 1?
no, just coincidence that the first term of the sequence happened to be the same as the first subscript. Okay, talking about proofs. How do I prove? Let me say one more thing about intuition before we go on. If I had written this on a pre-test before the semester, I think you'd have gotten it right. Right? You did limits in Calculus 1. What's this getting close to as n gets larger and larger and larger? 2, right? This term's going to 0, so the whole thing's going to 2. So this converges to 2 is equivalent to saying the limit as n goes to infinity of this thing is 2. That's the same statement. Where we're going over the next few days is to do something that mathematicians took 100 years to do. Figure out, what is this? As n gets really big, this gets really close to 2. What does really close mean? What is close enough? You know, how close? 1/1,000,000th? 1/1,000th? What is this gets bigger means this gets, well, how much bigger? 1,000,000? 2,000,000? So it took mathematicians a long time to write down a definition that made that precise. If you're building something, you know what close enough means. Because if you're boring pistons for a machine shop, for a motorcycle, you know that 1/10,000th of an inch is a big number. You're off by several 10,000ths of an inch. When you're boring the engine comes apart. So you just know from trial and error, to get it within 100,000ths, you got a perfect engine. You get it within 1/10,000th, your engine is going to smoke in seconds or not start, depending on which direction you went wrong. So in engineering, you often know what your tolerances are. But this is a very similar question to that. Let's talk about how we would prove a couple of these things. Prove 2 is an upper bound for 2 minus 1 over n equals 1 to infinity. If I had to prove that, I need to show that, so I need to show that 2 minus 1 over n is less than or equal to 2 for all n equals 1, 2, ... That's what I have to show. If it's an upper bound, every term of this is supposed to be less than that number. Less than or equal to. Okay, that's not hard. Scratch work first. 2 minus 1 over n less than or equal to 2. Subtract 2 from both sides. Negative 1 over n less than or equal to 0. Multiply by negative 1. 1 over n greater than or equal to 0. Well, if n is greater than or equal to 0, now let's do our proof. Proof. Let n be greater than or equal to 1. This means n is a natural number. So let it be a natural number bigger than or equal to 1. Then 1 over n is greater than or equal to 0. So negative 1 over n is less than or equal to 0. So 2 minus 1 over n is less than or equal to 2. All I did was reverse what I figured out over there. If you start with some positive integer bigger than or equal to 1, then it's positive, so its reciprocal is positive. If I multiply both sides of this equation by negative 1, I flip the sign. If I add 2 to both sides, the sign stays the same. Now I have, so a sub n is less than or equal to 2 for all n equals 1, 2, 3, ... Okay?
What's the big one for?
That means the natural number. That's a notation. This means this set. And this little element, that symbol, means is an element of. So this says n is an element of the natural numbers. That's just a mathematical shorthand. Yeah, later on in mathematics, all your sentences look like this. Just write everything in symbols because it takes too long to say for every natural number n, there is a t such that for all t greater than or equal to x, f of x is greater than or equal to 0. That's just too long to say in English, so we write it all in symbols. Okay. What would we need to show that it was increasing? Okay, what do we need to show? We need to show that the nth plus 1 is bigger than the nth, right? So I need to show 2 minus 1 over n plus 1 is bigger than 2 minus 1 over n. Scratch. Subtract 2 from both sides. Multiply both sides by -1. I knew there was a reason I took college algebra. So I remember to flip the sign. Multiply both sides by n plus 1. Multiply both sides by n. Whew. There we have it. Something that I believe is true, and I believe I can reverse all my steps. So proof. Let n be a natural number. Since 0 is less than 1, n is less than n plus 1, I think I'll just flip both sides right away. 1 over n plus 1 is, oops, got to flip my sign. Multiply by negative. Add 2. Here's my little symbol for all n equals 1, 2, dot, dot, dot. A sub n is less than a sub n plus 1. Okay. I'm hoping the proofs are sinking in what has to be shown to show it's increasing, decreasing, or a lower bound. Let's talk about what we're heading for with converges. Here's what we're heading for with converges. I know you've seen that little epsilon. I use it in 2 different ways, and that may be confusing. We think it's going to 2, right? This is the one, same thing. We think it's going to 2. It was 1, was A1, A2. We think it's going to 2. The mathematician's definition for going converges to 2 is the following. If you give me any tiny, tiny, tiny number, I'm going to call it epsilon. So let epsilon be greater than 0 be a tiny, whatever that means, positive number. Add it to 2, subtract it from 2. That gives me a little area around 2, doesn't it? Kind of a neighborhood. That's what we mathematicians would call it, a neighborhood. Now, I say this sequence converges to 2 means the following. No matter how tiny a number epsilon you give me, I can find a number n so that a sub n is in, I'm going to write between, is between 2 minus epsilon and 2 plus epsilon. And a sub little, I'll call it little m, is between 2 minus epsilon and 2 plus epsilon for all m greater than or equal to n. So what am I saying? What I'm saying is this. No matter how tiny a little neighborhood you pick around 2, I can find a natural number n so that not only is that term of the sequence in here, but every term of the sequence is in here where the subscript is bigger than or equal to that one. That's what convergence means. Convergence means you get in this interval at a certain point and you never leave it again. You get inside the interval, you never leave it again. So the first few problems in your homework, in my last 2 minutes, although that clock's slow, the first few problems in your homework say something like this. Let epsilon be, say, 0.01. Find the natural number n so that 2 minus 1 over n is less, I think I wrote it like this, is less than but let me rewrite that in a way that makes sense. This means 2 minus 1 over n is between 2 plus 0.01 and 2 minus 0.01. Because if you get rid of the absolute value, you throw negative 0.01 less than 2 minus 1 over n minus 2 less than 0.01. Then you add the 2 to both sides. This is what you're trying to do. Find me the natural number n so that this is always trapped between here and here. You can do that just by plugging them into your calculators. I don't know how many, it might take 10,000, you might skip a few. Or you can do the algebra. Just start with this side and try to work down and figure out what natural number n will satisfy that. I would like to have finished working that one out, but I'm out of time. But I hope I gave you at least a taste for what we're trying to show you about conversions.
So I'm working on 260 and the symbols of that problem, but the E isn't a number, it's just a positive number that's less
So n ends up dependent on that?
So could you say